background, crypto enthusiast. I think I went into cryptocurrencies in 2011. It was very difficult to get any cryptocurrencies at that time. The first few cryptocurrencies I managed to accumulate, I think, were less than $1. I was very excited after spending 6 months just trying to, what is this Bitcoin? I used to hear about it, then unfortunately it disappeared when there was a serious crash. People invested money, then all of a sudden, there was this great dive and then they lost. And the same thing happened not too long ago, 2017. And because of that, we see a lot of things happening around which we think is quite unfair. People don't really understand what this is. It's definitely our mission to try and make people really get the core aspect of what these cryptocurrencies are. But it's also important to understand how this thing works. It shouldn't be rocket science, and I believe it's not rocket science. Okay. So the title of this presentation is Blockchain, Introduction to a Blockchain. I like thinking about them as modern day pyramids on the cloud. I think we'll see exactly why I referred to it as that. So a blockchain basically consists of party A and party B transacting. So basically you're sending money from one individual to another one. Now the difference is that there is no counterparty or third party within a blockchain transaction, and only the blockchain. So basically, what we've done is we've removed the middleman that verifies a transaction has occurred between two individuals, and we've put what's called the blockchain in between. So there is public verification that shows that the transaction has happened between party A and party B. Anybody can verify that funds have moved from party A to party B. Unlike our typical banking transactions today, if I did a bank wire to some account in the Cayman Islands, only that bank and the receiving bank can verify this transaction. But on a blockchain, we can see every transaction that has ever occurred, from the first transaction that ever happened on a blockchain. Now I want to mention that there's different types of blockchains. There's something called the proof of work blockchain and proof of stake. These are terms I'll just encourage you to go look them up. It's important to understand. Basically, in simple terms, a proof of work blockchain means when I'm sending value from party A to party B, this blockchain has to prove that some work has been done for value to have moved from A to B. There's something called mining. I think someone asked about mining. Mining is a process in which transactions are confirmed on a blockchain. Who owns miners? Miners are owned by individuals. And they're incentivized to own mines or mining farms because if they confirm transactions, they get paid for doing that by the network. It's very interesting. It's just a bunch of computer systems that actually incentivize individuals to keep them alive. And this is going to become very interesting when we start looking. I think there's a lot of talk about artificial intelligence and how payments will happen between one machine to another one. We can already see where this is heading to. So this is a practical example of how a blockchain works. If I send money from me to Japhet, there's a question that's asked. The blockchain basically asks a question. A bunch of people have these computers and they are waiting. Everybody wants to be the first person to confirm this transaction. So this blockchain asks to say, could you please solve this problem? If I had asked you here, I would have said the first one to solve this problem will get an award, maybe 20 kwacha or something. And that's exactly what happens. And if you get this correct, and the second person gets it correct and tells the network the correct answer to this is ABC, that becomes valid. The first guy to have actually solved that problem is the one that wins the prize. So basically, if all of us were transacting in this room, there'll be a bunch of computers out there waiting to look at these transactions. And then these computers are required to solve a very difficult mathematical problem for them to be able to claim the reward. First of all, they claim the fees which you are paying to the network for you to transact, because obviously the network is not going to function without some incentive. It needs an incentive, and the miners need an incentive. So you pay the network a fee. At the same time, the network is going to pay the owner of the mine that confirms or validates the transaction. In this case, the counterparty, the blockchain computer system. So this is basically how the computers do it. There's something called SHA-256, some computer jargon, but it's basically encryption. What happens here is a simple example here of what 0 looks like in a SHA-256 algorithm. It's very simple. If you go to Google, you can find some calculator to convert that into SHA-256. So what happens is that when we transact, when I send A, B, the computer is doing something like that. And when I go to a public blockchain, I'll find some number, like this. If I click on that number, I'll be able to see which party was sending money, to who was sending money, who was transacting. There's certain information I'll see, but there's certain information that I will not see. So usually they use some 256 random number, hash it multiple times. The input is something called the public key. Now, it's very important to understand what public keys are. When you are sending money to an individual, you send to that individual's public address. Now, this is called the public key in terms of this computer jargon. You send using something called a private key. We'll see where it comes in later. So don't worry about the confusion. This is just basically in simple terms, there's a very difficult mathematical problem that needs to be solved by a blockchain in order for transactions to be confirmed. This is basically a heat map of those computers that I mentioned and how they are spread out throughout the world. Here's my vector. So we can see, huge clustering around Europe area in the Americas. China is quite big on that in the islands here. I think it's Japan, India. A little bit of activity in South Africa. Zilt in Zambia. There's opportunities for people to actually run mining farms with confirmed transactions. What this means is that transactions, if let's say there were miners in Zambia with sufficient computers that can confirm transactions very quickly, it actually makes the blockchain network confirm those transactions very, very quickly. And whoever runs a mine in Zambia actually gets those transaction fees from the network. So that's quite something quite interesting to view. You can see that it's a global network. The Bitcoin network has been running ever since it came up. It's had more than 99.999% uptime. It has never gone down. Okay, so now what is the big deal? So first of all, it's distributed. You can see from the previous heat map of how these things are spread. It's a distributed network. It is public. Like I mentioned, you can verify that transactions are moved from one party to another one. You can see that on a public blockchain. It is immutable. This is a very important point. There is no rollback of transactions on a blockchain. If you send money to the wrong person, there is no one to complain to. There's the network, and it's not going to give you your money back. Unless the other individual that you accidentally sent money to, is a humble person and understands your problems and sends you your money back. But there's no one to complain to. Your money is lost. And it's a ledger. Basically, it shows that, value moved from A, value moved to B. This same value that went to B eventually will move to C, D. You can see all the transactions that ever happened on the Bitcoin blockchain network. By the way, I'm referring to Bitcoin because it's the most popular cryptocurrency. There's a whole bunch of cryptocurrencies, but this is the easiest one to explain. So why don't we just call it a database? We don't call it a database because the database uses something called CRUD. You create records, you read, you update, and you delete. But on a blockchain, there's only two things that can be done. You can read many times, you can only write once. That's where the non-reverse of transaction comes from. So it is not a database. It is actually a public ledger of transactions. Then decentralization, like I previously mentioned, there is no owner of the blockchain. The blockchain is owned by the network. The network is composed of people that own miners and what we call blockchain full nodes. They're basically enthusiasts who just want to see this thing grow. So they run these computers that help validate transactions. They don't mine, but they have computers that help. If I solve a problem, that problem that I talked about when I'm sending transaction between A and B, if I solve it and I have a miner, and my colleague next door has something called a full node, his full node is going to tell the network that he solved it first, Mulima solved it first, so give him the reward. That's the work of full nodes, basically. So these are some of the concepts in this network. So again, let's look at the big deal. Typical transactions, like I mentioned, will involve a middleman or a validator, or usually there's something called escrow. When you send money, someone still has to validate that you've received a good or a service before the money is then remitted to the party that you were sending. But on a blockchain, there is no middleman. We replace that with a network of machines. And now how sure can we be that a digital transaction will not be restored? Remember that there's a very difficult mathematical problem that needs to be solved, and 100 people verified that I solved it first. So if someone wants to hack the Bitcoin blockchain, they have to solve that problem and tell the network that they solved it. But there'll be a conflict because the network will say, wait a minute, there's a guy that solved it a year ago. So if you want to change that transaction, you have to change all the 1,000 transactions that have occurred since then. So that is how safe transactions are on a blockchain. Basically, we believe it is never going to change. Of course, there could be arguments, Yeah, what if someone makes a very powerful computer that can do that? But who's got the money to make such a computer? And in any case, the network keeps on growing bigger and bigger, bigger and bigger. You have to make sure you convince all those networks throughout the world in order for you to hack the Bitcoin blockchain. So now, there's something very interesting I keep on hearing. People saying this is just a hype. It's not going to go anywhere. It came and it died. Something interesting about technology. The hype around Bitcoin blockchain technology is exactly where the internet was in 1991. Very interesting, if you go to YouTube, you will find videos where, people have been talking on CNN about the internet. The technical guys were telling people, this thing called the internet is going to revolutionize and change the world. And then the guys at CNN say, so what can you do on the internet? And the guy says, you can send mail to your friend across the world. I said, but why can't I just write regular mail? This thing is pointless, right? That's where it seems to be right now. But it's only people who can really see the implications and the kind of problems that I've solved that would understand that this thing is going somewhere. And I'm here to tell you that you will never hear the end of blockchain in your lifetime. It is here to stay. So, governments banned the internet. Interestingly, people were not allowed to use the internet because they were thinking national security and stuff like that. What do we see about blockchains today? The Chinese government is shutting down mines. This government is trying to regulate them. The internet went through that phase also. Technology goes through those phases. Telecom companies banned the use of modems. Interesting, if you have a modem, they claimed modems were causing noise on the lines when people were using them, and they scoffed and laughed. Some people told telecom companies to say, in the future, all your services and international connectivity will go through the internet. They laughed. This thing can only do 2 Mbps. What are you talking about? That's the same argument we hear about blockchains today, saying you can only confirm transactions less than 2 Mbps per second. What is that? Current systems are capable of doing that. We hear that argument today. Human nature and systems fight what they consider is a threat to their existence. The modern way of doing things is under threat. I heard from the IMF boss recently, I think last week she mentioned that blockchain actually is a threat. It's actually disruptive to the traditional way in which we've been doing things. So think about it as disruptive technology. It's coming to change the way things happen. They said cars were noisy and could not work because they tried to run cars on roads that were meant for horses. So usually, if you introduce a technology and you try to use legacy infrastructure on that technology, yes, it will have problems. They were driving cars on roads meant for horses. There were accidents every day. We see us trying to apply blockchain to systems that are impractical and don't make sense because the infrastructure hasn't yet caught up to that. But it will catch up. So to prove how bad AC power was, Thomas Edison electrocuted an elephant in public. He would be arrested today, but he was allowed to do that. He wanted to prove that AC is useless, DC power is the best. We see this happen in technology. We see that happen in blockchain today. Bashed left, right, and center, no use cases, not practical and stuff like that. But then, the most important thing is this. There is no third party in transactions. And I can tell you one thing. The next time you see self-driving cars on the roads that go and pay for their own power, there'll be some sort of blockchain technology behind it and exchange of cryptocurrency. So where are we? This is something interesting. It's called the hype cycle of technology. It's basically what I've been trying to explain. Technology tends to go to a plateau. You start hearing about it so much, it's overly hyped. People have, unreasonable expectations as to what that technology will do. Before disasters happen and it comes down there, this is an example of virtual reality and where it is today. I believe blockchain should be somewhere. Here it is. So this is about 2 years ago, so this should be updated. I actually believe that we're coming somewhere down here. We're beginning to find practical use cases of blockchain technology. And it's going to mature or probably get to where VR is in quite a short period of time. Which case this is 2017. In 2019, I can definitely tell that we are definitely away from here. We were at the hype, the time when everybody thought they could make money out of blockchain cryptocurrencies. I mean, everybody in Zambia heard about it. We were seeing all sorts of things happening. Warnings were issued and stuff like that. When you get to a point at which everybody seems to be able to understand what this is and everybody thinks they know what they're talking about, your hype is at a plateau. When they get very disappointed because something very bad happened to them and all of them just pull out and suddenly it's very, very quiet, then you're getting to maturity. So then, security. How secure transactions? How secure are your coins on the blockchain? Because remember, you have the value, you are sending a value to another person. I mentioned something called the public and the private key. It relies on something called public-private key cryptography. The easiest way to think about it is this way. You have a lock, and your colleague also has a lock, right? But only you have a key. So you have a lock key pair, and your colleague also has a lock key pair. So what you do, imagine you've got 100 of these locks. So you distribute these to each of your friends. And whenever your friends send you a message, they send it with your lock, because only you have the key to open it. And the same thing happens the other side. You are trying to send the message to your other colleague this side. You lock the message with his lock, for which he only has the key. This is what private-public key cryptography means. So if I've got a public address and he's trying to send me information, he will use my public address, which is my lock, to send me value, but only I have the key to open that lock. So that's only I can access the funds. So how safe are your funds? Your funds are safe as your key is. So basically, this is a very important thing to note. Security is dependent on you keeping your private key safe. So now, fortunately, this is handled by software. If you download what we call a wallet that's used to send transactions, it manages these keys for you. But it's very important for you to understand this. It's quite possible one day you forget the password to log into that particular wallet you had. But if you know what the lock and the key is, you can generate your key for every lock that you've ever used and have access to your transactions. The good thing is that even if you lost your phone, and as long as you remember that key, or you have that key somewhere, you wrote it down, you laminated it, you buried it under your bed somewhere, you always have access to your money. So always think private key security. So what are the benefits and potential of blockchain technology? I like thinking deep and looking at the practical applications. One thing is definitely machine-to-machine payments. We've heard of M2M. Where does this come into practicality? We've all heard the jargon of what is IoT, Internet of Things. We've heard that word. But how practical is it? Usually what happens is that, if I've got some sensors somewhere in the world, I have to manage billing for those sensors to access the network. But you can imagine a world in which, machines can pay for their own services. Machines can pay for their own electricity. Imagine that world. That's only possible with a blockchain. So we have smart electronics, autonomous vehicles can take advantage of this thing. Global e-identity, we'll see an example very soon of what this means, because public keys are unique across the entire blockchain. It's quite possible that each of us could have a digital identity, a global digital identity on the network. And at some point, I think naturally the world is progressing towards that. We need to be able to uniquely identify every individual. Something called smart contracts. Smart contracts are contracts that are implemented on the blockchain. Instead of having my good lawyers verify it, they simply tell me, what's involved in that particular contract. Of course, they have to explain to me. They're still relevant. They'll always be relevant. Lawyers are always relevant. So they explain to me how exactly this contract is supposed to be framed. I program it into a blockchain, and then it automatically, has these agreements approved between two individuals, and these agreements are forever there stored on the blockchain. Proof of ownership of digital products. This could come very interesting when we come to deal with issues related to piracy. How do you make people not pirate music, movies online? There's been issues with how to manage this. I believe we can use blockchain for that. Things like proof of life. Something very interesting happened where Julian Assange, when he was in the embassy there, people knew that this address belongs to him. They thought, something happened to him, he died or something. And he said, I'm going to prove it's me. And he said, but how can you prove it's you? He says, I've got the private key and nobody else has. And I'm sending a transaction from here. So they were like, yeah, the transaction came from the embassy and they used his key, so it must be him. That was the first case of proof of life over a blockchain. Very interesting application. A true global distributed storage system. Forget about Dropbox. Forget about Google Drive, Microsoft OneDrive. You can store your files across the biggest network that's not owned by anyone on this planet, on a blockchain. 24/7 central banking. The banks never sleep if they begin to start using this. Open and free elections. Anybody can verify that someone voted for A, B, C, D. There can be no duplication of voting. In fact, there's been cases where this is being talked about in the European Union, trying to implement this. Cost reduction in remittances. real-time international bank transfers, universal currencies that are state independent. So basically, but the blockchain has limitations, like I mentioned. The blockchain is not a database. A blockchain relies on communication networks. You need a communication network. You need electronics. If there's a blackout in this country and all you had was Bitcoin to do transactions, and you had no phone, you had no internet, you have no money, you're broke. I think that's a bit of a challenge that needs to be looked into. It's complex right now, and the lingo, I think you've probably heard, it's very complex. We need to make it very easy for people to understand this and to be able to use the technology without understanding the jargon behind it. People use phones today and they install apps without understanding how Android works and stuff like that. They pick it up and they use it. Now we have to explain so many things before someone just uses modern day blockchain applications. Storage issues. You can see the Bitcoin blockchain has been growing exponentially. Right now the size of a Bitcoin blockchain is 250 gigabytes. And this is just headers, not even all the information. It's huge, and it keeps on growing. So the question is that, are there going to be computers in the near future that will be able to handle one file or process one 250 gigabyte file to extract information out of it? This is a challenge that's still being solved. Use cases. In Estonia, they have something called e-identity in Estonia. They've got a blockchain, and all the citizens' information is stored on that particular blockchain. Anybody can verify information, and not even the government can change information on the Estonian blockchain. If the government committed to something and put it on the blockchain, it's never going to change. The information is there. This is very interesting. It's one of the only countries in the world that has 100% e-government, and they rely on blockchain technology. Other use cases, asset tokenization. It's interesting because now this is actually happening. A building that's in Dubai can be broken up into small individual pieces, and everybody can own a piece of it. You buy through something called initial coin offerings, and you own part of that building, and they distribute dividends or profits to the holder of that particular asset token. Very interesting. Transparency in supply chain management, distribution, healthcare management. Right now we've got a problem with healthcare. If you go to one clinical hospital, the files are kept there. The next time you go to another clinical hospital, your initial files are there. They want a reference. They probably won't send all your files to the new location you're going to. And basically all the information is lost. But imagine we can access this information from anywhere in the world. If you go to a hospital with your global e-identity, we're able to access your global e-health information, and it's very, very secure. So potential obstacles. There are obstacles I mentioned, like the block sizes, legacy internet infrastructure, lack of blockchain engineers. This part is quite critical. There's very few blockchain engineers around, and it's one of the hottest things out there in terms of people trying to look for work and applications and programs. And legal and regulatory concerns are definitely big. Thank you.